This is the second video in my data screening collection. So in this one, we're going to cover missing values and how do I fix and deal with missing values and really get into multiple imputation of missing values. Okay. So let's first look at our no typos data set and see what it has. And so if you're just joining me on missing values, you might want to go back and watch the other ones because I'm working through this in order. So I'm going to do a summary of my no typos. And I can see, if you just use the summary function, that you have several NAs. So going back to my Word doc here, now we're on missing. And so, goodness, the first thing you want to do is really use the summary function or the table function to check out where my NAs are. And so we can see that I have created some NAs in this data set across nearly all of the variables. And then let me go back to my PowerPoint here. So let me just talk a little bit about missing data firsthand. So missing data is really an important problem. And you should stop and ask yourself, why is this data missing? Because that will change what you do next. So did you forget to enter the data? Is there a typo? So in the last video, we created some missing data because we fixed some typos. Is it because everyone skipped the same question that's problematic? Or is it because they quit halfway through because they're freshmen and we're doing intro to psych students and they got sick of taking a survey? And so that's happened to us a lot. So there's two big types of missing data. So there's MCAR, so missing completely at random. You do want that type of missing data if you have to have missing data at all. And then there's MNAR, and missing not at random. And that's bad. So missing not at random data is not good for you. Okay. So there are ways to test for MNAR versus MCAR, but honestly, unless you just really need to prove to someone that data is completely at random, you can usually just kind of see. So random data missing, so MCAR appears randomly across your data set. If everyone has skipped question 7, that is no longer random. So you can click on the data set to view it. So here's my no typos. And I can see that the NAs appear fairly random. Or you can get to doing some of the functions I'm going to show you in just a second. But here's a not random. So I have data for their for the first part of the survey, but not this survey. Okay? And so this might be that they took the other surveys in the experiment, but they didn't take this survey. So I don't want to import their data because then I would be making up an entire survey for them. So MCAR data is often caused by just skipping a question or missing a trial, or if you're doing survey software like in Qualtrics and you've got 10 questions on there, the little dots line up kind of close together sometimes, so it's a little hard to tell you've missed a question. MNAR data may be the question. So we used to have a scale that we would use that would ask people, do you do drugs? So they'd say yes or no. Well, if they said no, one of the next question was, can you quit drugs when you want to? If they said no to the drug question, they didn't know what to do on that particular item, because if they said no because they don't do drugs, it made it sound like they had a problem. If they said yes, it made it sound like they did drugs, and so people would skip it a lot because it didn't apply to them. And so that would be not at random. And then the next thing you have to think about is what can I do? So how much missing data can you have? And the general rule is about 5%. So this is not can I have really, this is can I import? So how much missing data can I replace is really what this slide should say. And let's just do that. So if you decide to replace, how much can you replace? In large data sets, replacing with things with less than 5% is usually okay. In small samples, you're going to need to probably collect more data. Now, if you're dealing with a data set that only has 5 columns, skipping any one missing point is going to make a person have more than 5% missing data. And so on that one, you may be able to just go by columns, but you got to be really careful. Okay. So there's a big difference between missing data and didn't finish the experiment. So missing data is missing completely at random. Didn't finish the experiment is missing not at random. Okay. So how do we check if I decide to impute data, that's going to be a big deal. So I could try running the analysis with the missing data set and without the missing data. So imported versus not imported. So we're going to create a different data set here. And so the great thing about R is it's really easy. You just change the name of the data set you're using once you get to your analysis. The bad thing about doing that in SPSS is you have to save as multiple different data sets or use the filter function. And so this is one reason I like R, is because it allows me to do this sort of thing very easily. So let's say you decide to delete people instead of replacing them. So you can also delete folks, and you can exclude them either pairwise or listwise. Preferably pairwise. So pairwise excludes people when they have missing data for that analysis. So this gets a little confusing sometimes because your N might be different across the same research paper, but then you're using people when you have their data and excluding them when you don't have their data. So that makes sense, and you haven't wasted the participants that did take the study but maybe didn't answer that particular scale. Listwise would exclude them completely. Listwise is a little easier, but pairwise is a little bit more powerful. If you have a variable with lots of problems, you might be able to exclude it. So for example, we're trying to publish a paper on peer-assisted study, and we decided to control for the sort of smart kid factor, that the higher achieving students are more likely to go to peer-assisted study than the lower achieving students. And so we had high school GPA or high school rank or ACT scores. Well, the problem with that was we have lots of non-traditional students at our university and lots of transfer students. And so, well, the biggest issue is that those students don't have to turn in that high school information. And so we had lots of missing data. So we ended up having to just exclude that variable and use a different one because it just had too much missing data and it was going to delete most of our data set. So, example of when you might change your mind about a variable. So there are ways to estimate to fill in missing data. There are lots and lots of ways. I'm going to show you one of them. And it's probably, to me, one of the easiest ones that does most of the hard work for you. So the most popular thing to do in the old days was mean substitution. So mean substitution is where you fill in the average for that particular column. So if the average of RS2 is 4.5, I would fill in 4.5 for every missing data point. And that's actually the default in SPSS. It is fairly conservative in the sense that it does not change the mean value. So it doesn't change your average scores. However, it does change the variance. It lowers the variance because you put more scores on top of the mean. That reduces variance. Because it reduces variance, that creates the chance for more of a type 1 error. So it does make it easier for you to find a significant difference. So this is where that 5% rule came in, because after some simulation studies, people found that fill in less than 5%, it doesn't tend to affect the data that much. But it can make a p-value flip from good side to bad side, the dark side of p.051 to the good side of p.049. And so most people don't recommend this procedure anymore. The reason it was so popular is because it's easy, and it's certainly mathematically easy as well. Multiple imputation is not easy. You can't really do that by hand, nor can you do expected maximization. So this really is considered the best way to do things. If for a while, SPSS does offer this plugin if you're interested in that, but it's several $1,000s for one computer. So it's not really feasible still. There are other options in SPSS. If you're interested in those, you can go watch my video on that. But in R, it's actually really easy. So that's the great thing, is that we're going to use a little package called MICE for Multiple Imputation Chained Equations. That's what it stands for. And it will do the heavy lifting for us. But the idea of multiple imputation is that you run multiple times. You look at the data, what I call across and down. So the data, where you look at the row column, the average column, and then the row average and the column average and the row numbers, and sort of predict the best score for that participant. And expected maximization is where you create lots of different scores and you pick the most likely one. Okay? And so we're going to multiple impute here. Okay? One big thing is, and this should just say don't replace, take out the word mean here. That's left over from my SPSS days, but don't replace categorical variables. Or demographics really. That tends to make me nervous because it's hard to guess based on row totals and column total or row and column averages what gender someone would have been, or what religion, or what political party. So I tend to tell people just don't replace those categorical ones. And I'm talking about demographic variables here. So really this should be categorical demographic. If you have a categorical variable that's part of the dependent variable, you can impute that, and mice will do that for you. But just in general, that's my kind of general rule. Don't replace those. So you can either leave them out or do pairwise elimination. And we're going to talk about the easiest way that I have found to do that in R. And if someone watching has an easier way, let me know, because this is sort of the hack that I've put together. And so this is my ultimate sort of missing data flow chart here. If it's categorical or demographic, stop. So don't replace that sort of data. If it's continuous, let's keep going. If it's missing and not at random, so they quit taking the survey or everyone has skipped question 7, stop. Don't replace that data. If it's missing completely at random, so just, it's an accident, but it's more than 5%, don't replace that data. And if it's missing less than 5%, mice it. So we're going to use the mice package. So the first thing you have to do is figure out what can I replace. So this is getting through all of these steps. How do I get to this point here where I know what I can mice out? And so we're going to find percent missing by column and by row. So let me start down here. And so what we're going to do is first take out the categorical variables. And so I'm going to do a new data set. Let's see, what do we want to call it? Where I take out missing data. So let's just keep going with no typos, and we'll call it something new here in a second. So I've got to drop those categorical variables. Remember, those were 1 and 3. Okay, that's in the last video. So the first thing I want to do is figure out what they are. So I'm going to type names down here. No typos. And so I want to drop sex and SES because those are categorical. So that's dropping columns 1 and 3. So the very first thing I want to do is do no typos, where I drop columns, so negative 1 and 3. Now let's just look at what that looks like. Okay. And so that drops out gender and socioeconomic status. Okay. And so that's the first thing that you got to do. So we've taken out those categorical variables. So let's look at columns now. So what columns can I replace? And really this is actually looking at columns. So let's do it like this instead. So let's look at columns. First thing you want to do is take out the categorical columns or the other columns. Now let's look for greater than 5% columns. Okay, we're going to fudge a little bit, but greater than 5%. And so what we're going to do is use this make our own function and use apply. So go back here. Let's write a function. So we're going to make up our own percent missing function. And so I'm going to call this percent miss because that makes sense to me. And this is sort of commented out here, but we're going to say function x. So anytime you type function x, that tells R that you're going to write your own little function. X is just a placeholder here. And so I want to do is an AX. Is an AX tells me if it is an A. If it is missing, you get a true, which adds up to a 1. If it is not missing, you get a false, which adds up to 0. And so the sum function, unsurprisingly, adds all those up. So it counts the number of 1s to 0s. So it totals the number of NAs based on either row or column, depending on how we use apply. It divides by the length. So the length is how many things did you have. Okay, so this is a percent we're going for. So the total number of missing divided by the length. Multiply that by 100 so we can get a percent. And that closes the function. So the whole thing looks like this all typed out. So percent miss, you can call it whatever you want. So function of x. So it changed to purple because that's a reserved word. And reserved words just mean they're words that are saved in R in a special way. So you can't call something function. Don't do that. It's bad. So what did I do? I said I want to sum up the NA values of x. I want to divide by the length of x. And I want to multiply the whole thing times 100. Because R understands please excuse my dear Aunt Sally, that will go in order. But since it's multiplication and division, it's all the same, really. Okay. So when I save that, it's going to come up over here as a function. And so that is our new function. The problem is that doesn't save permanently. So anytime you want to use that function, you have to run it again. So how do I check for columns? So to check for columns, we're going to use the apply function. So we're going to apply this to our no typos data set. But remember, we've got to drop those columns. So I got my negative 1 and 3. Remember, it's 1 or 2 for rows and columns, so 2 for columns. And now I'm going to type in percent miss, and it's going to run my new function for me. So let's see what happens. When I run that, I have now the percent missing for each column. So I've got 3 less than 1%, blah, blah, blah. So you see RS3 here has right over 5%. I'm going to round down, so that one's okay. But RS8 over here has 7% missing because I made it happen that way. So RS8 is bad. So I don't want to replace data in that column. Or was it 8 or 7? Let me make this a little smaller real quick so it lines up. Okay, 9 has 5.1, but that's okay. Let me round down. So 7% is bad. And so when you're doing columns, you're looking for anything over 5%. So the first thing we're going to do is exclude that column for future use. And that is what that sign means. Let me go back here. And so I am going to just real quick do names and then do no typos again. And I'm going to count for RS8. So RS5 is 10, 11, 12, RS8 is 13. So I want to exclude column 13. Now there are fancier ways to do this, but I'm going to do this kind of by hand just so you can see what I'm doing. Oh, and did I just type apply on the bottom? Oh, no, I did it down here. Sorry. There we go. Now let's do rows. So I'm going to do apply, same thing, no typos. Don't put a space there. There we go. And I'm still excluding my categorical data because that's one of most, I don't want to worry about that. I'm going to do 1 for rows and do percent miss. And what that does is it actually gives me every single person ever, and that's way too much information. So let's save that as something. And so now I have all of that information saved in this missing code. And so there's a ton of data. But I just want to see what's happening. So I'm going to take a summary of my missing data. And so that shows me the average. So the average is 3.5. Okay, maybe a table instead of my missing data. That's a little better. So I have, scroll down here, 109 people with no missing data, 16 people with 5.88, 4 people with 11.76, 4 people with 17.64, etc. The table function may not be super useful to you if you have lots of different values. So if you have 200 columns, that might be a little crazy, but it works okay for me to see. What do I want to do with that? Well, I'd like to exclude people who have more than 5% missing data. So I'm going to show you 2 routes with this. because I've gotten a lot of questions about this week. So I looked at columns, and then I want to check out rows. Okay, so saved as missing. Okay. So now we're going to, we've figured out, let me go back real quick here. There. So we've excluded our categoricals. We've figured out our not at random. And that is the people who have more than 5 missing data percent points, or they've skipped the whole survey, that sort of thing. And so really this whole thing is broken down into one step. My completely at random, I'm going to go less than 5% and I'm going to mice. Okay. So we've worked our way through this table. And so I want to eliminate the bad rows and the bad columns. Okay. So we're actually going to do this a little crazy like. On here it's got 6%, but I'm going to show you what happens with 5% first and then do 6%. And so I'm going to break this down into little puzzle pieces essentially. And I will try to draw this for you in Word. And so what we're going to do is we're going to take the entire data set. So let me give a little one by one. So here's the entire data set. Okay. And so it's broken down into rows and columns. And so I have our whole data set. And we're going to start by breaking it apart by rows. We're going to start with rows for a reason. You could do this the other way, but rows is a little easier. And cut out the bad rows. So I'm going to cut out these bad rows. So I'm essentially saying, now this isn't the whole data set. This is the good replace rows. So these are the people I want to replace. So somebody, one of my students call this replace rows. That may be a little more logical. But these are the bad, don't replace rows. Okay. And so this is don't people. And so I'm splitting the data set basically in half. And so I'm creating 2 new mini data sets where I have people I can replace and people I can't replace. All right, let me do that first here. So we're going to separate out by rows. And that is actually what's in this slide here. It's got 6 on here for a reason. But let's pretend and do 5 first. Okay. So replace people. So these are the people I want to replace. You can use the subset function or you can use the matrix format. And I did mine in matrix format, so no typos. Okay. Where no typos, $sign, or no, sorry, missing. It's not in that data set, that's okay. It's less than 5%. So remember, logical operators searching by row give me all of the columns back. So this is going to give me all the columns at once. My missing piece is actually not part of that data set. I didn't combine it into the data set, but that's okay because it's in the exact same order as our other data set, and so it'll match based on participant row. Okay, so it'll say number 1, 2, and 8 are missing too much, which will match to participant row in our original data set. Okay. So with replace people, that breaks it down into 109 observations, right? Because here, look at the table. This is 5.88, so it's really going to exclude everybody who does not have missing data. So this is 0, so there's actually no missing data in this. Now let's do don't people. No typos. We're going to do the exact same thing, but in reverse. Missing data is greater than 5%. Okay. And that's everybody else. So our 2 data sets should add up to the total. So 28 plus 109 is 137. The next thing I'm going to do is separate the bad columns out. So this is 1, 3, and 13 for our 2 categorical columns and the 1 column with too much data to replace. I'm going to call this replace column and don't column. So here, what that means is what I've done is I've taken this this data set only, so my replace people, because basically our don't people we don't care about right now. And I'm going to break this in half. So just this pin. And so this now becomes replace column, and this one becomes don't column. Okay. So these are columns over here that are categorical or too much data. Okay. And so this is now only the rows that you can replace less than 5% column and row. Okay. This one's just less than 5% row because the columns we've excluded, and then this over here is more than 5% row. Okay. And that just sort of Lego pieces our data into different subsets that we can then add back together later. So we're going to do that same thing, but now exclude columns. Okay. So we're going to do replace column equals replace people, okay, where I have all the rows minus 1, 2, and 13. Okay. So we've dropped 3 of the columns, so 16 variables here. And then don't column is replace people. It's the same data set, so both of these need to be the same data set, here and here, here and here. And it's the exact opposite. So see, I want 1. Ooh, no, it was 1, 3. Sorry, 1, 3, and 13. That would have been bad. So replace column has 8 grades, absence says great. Don't replace column is our 2 categorical variables and our 1 delinquent variable with more than 5%. Okay. Now, let's run mice on that. So I'm going to create myself a temporary placeholder data set. So the first thing you want to do is install the mice package if you haven't. And so you can click over here on packages, click install, type in mice, it will find it, or install.packages. But let's definitely load the mice library. This next piece won't run. So I'm going to create a temporary data set called temp no missing. And the way mice works is the code is mice, the data set name, which is going to be replace column. Okay. I don't have to do replace people because replace people has now been broken into 2 pieces. So I'm going to do replace column, and that's it. There's lots of different things that go on in mice where you can set lots of things to do. Do bays, do this, do that, do logicals, do this, do that. But without any extra added pieces, what mice will do is it will figure out the type of data that is in that column, int, num, logical, character, and replace it with that type of data. And so it's actually a fairly smart function in that it will figure out most of it for you if you don't want to be super savvy about setting a bunch of functions. If you're super interested in all the different parts and pieces, you can control every single last piece. But I'm like, you're smarter than I am, you just replace it. Okay? But if you want a little more control, there are more options. Okay? So it figures out what and how to replace for you. And so before we do that, let's try running this. Okay? So this is the function that actually will do the multiple imputation and create you multiple options. So I'm going to run this, and you're going to see we're going to get an error. And the error is fairly simple. No missing data found. And you're like, but I know I have missing data because not only does my summary, my table, tell me that there's missing data, my no typos data set clearly has missing data. Oh, sorry. Brain fart there for a second. So clearly I have missing data. Now, do remember that we have created a new data set. So we're actually micing on replace column, not the no typos data set, because we're creating a new data set as we go here. So let me look at a summary real quick. So if you get this error, I feel like it's fairly obvious. There's no missing data because the error is no missing data. But if you're unsure, you can try running a summary on that function. And I could see quite clearly, because there's no NA lines at all, that there's no missing data. Now, mice will not run if you do not have missing data, because it has nothing to impute. And it just kind of goes, I don't know what you want me to do, because I want to impute some missing numbers, and there aren't any, so I'm going to go back to taking a nap. Right? So if you don't have any missing data, by the time that you exclude everyone, basically, you could skip this step. Okay? And so you would skip the next couple of things I'm going to show you and just combine your columns and rows back together. So you would skip the whole replacement thing, which to me makes sense. If you don't have any missing data to replace, you skip that step. So in any of these brain farts, so in any of these steps, if you don't have problems, you skip it. Okay, that should be fairly obvious, but just to make it clear. But since I want to show you how mice works, I'm going to go back and fudge just a little bit and make this 6. So the problem really is that I have missing data that's kind of low. It's close. It's 5.88. So I'm just going to fudge it a little bit so you can see how this particular thing works. But remember, the rule is 5%. Okay. And so now if I run a summary on my replace column data, you'll see I have some NAs and it's going to fill in. And it's not very many numbers. It's one here and there. All right, now if I run this temporary thing and tell the mice to work, you're going to see some action. So this is it figuring out what to replace. But that's not the data. And so our replace column still has missing data. So down here, if I do that summary function again, I still have missing data. So it hasn't done anything. It's imputed them and then it's saved it as this list. And what that list is a bunch of the data saved. So now I want to take my replace data and put it back together. And so that is the complete function. Complete is part of the mice package. You can't use it in any other way. And then, so you want to use the variable you just saved. And then this number out here is which imputed data set do you want. There are way more functions on this where you could keep them all, but I find it easier if you just pick one. So pick a number between 1 and 10 because that's how many it imputes automatically for you. And so I think it's 10. It might be 5. It might be 5. But I'm pretty sure it might be 10. Can't remember. I swear it's 10, but whatever. So pick a number between 1 and something that runs. And I'm going to call this no miss because this is my no missing data set. So I've saved a new data set. So let's do that. Completes. So the complete function takes the imputed data and combines it together. And now if I do a summary of my no miss function, now I have no missing data. I have no missing data because my replace column has been fixed. So if you look at no miss here, it's 125 observations. Replace column, 125 observations. So it's not dropped anybody, it's just filled them in with the first imputed data point. Okay. All right, now we have to put everything back together. So you separated out your demographic columns and your columns with too many problems, but you kind of want those columns later. Okay. So I'm going to combine them back together so I can use them again later. And basically what I'm going to do is the first thing I'm going to do is combine these two back together. If you try to combine rows back together first, it's going to freak out because this one has way more columns than this one does. So if I try to take replace column and add in the rows first, it's not going to like that because the number of columns differs. So replace going across first. So not replace, sorry, or combine back together. So to combine two sets of columns together, we're going to use the cbind function. So, go back here. So I called this filled in because that's the data set name. And I called it none originally because it's filled in with none of the people that were the problem, but you might find a better name for it yourself. So I'm going to cbind those together. So I'm going to do don't column, and I'll combine that with my no miss data set. So my filled in none data set now has 19 variables, so I added the 16 variables to the 3 variables I had here. And then I created a filled in missing for people who have missing data, and that's going to be the rbind function. So let me go back here. So now I've combined these two things back together, and I want to combine the rows on the bottom, so I'm going to stick those on by using rbind instead of cbind, because this is a row bind. And so I'm going to do filled in none, because you have to use the data set you just created here, otherwise you will get a mismatch error with my don't people. You can do it in either order. I just stuck my demographics back on the front. Okay. So my filled in missing data is now back to the original size. I have 137 observations with 19 variables, and that includes my missing people who I didn't want to fill in. If you want to go list-wise, that's the data set you'll use, where you exclude all people who have too many data points. If you want to go pairwise, you would then do the rest of your analyses on this one, where you have the people who are missing some data points but not others. All right, we did all of this, and then that is the last slide. So from here, what I'm going to do is then go over how to calculate for outliers. And so that's going to be the next video. So this really just talks about one of the many multiple imputation packages in R. To me, mice has been the easiest one to work with. I've tried a couple. And then what to do if you get the no missing data error. Basically, you would skip the mice part and basically combine them back together. So you could do this line to combine your columns together. And you probably want to keep out the people who are missing too much data. But that's up to you at that point. But if you don't have missing data after you sort of exclude everybody, you don't have missing data, so you move on.